This is the QuickField simulation example. Our ISO 177 standard, test case 5, roof window frame section and insulation panel. This is the example web page on quickfield.com. Here we can find all of the necessary information regarding this simulation. This is, for example, the geometry model with lighter blocks and the edges. For instance, here we have the cool side of the frame section and warm side here, and also we can see the main dimensions given here as well. Also, general connectivities of the insulation blocks are listed here, and our task is to calculate two-dimensional thermal conductance in accordance with ISO standard. Reference thermal conductance is given here in colors. And one should note that to do this task, we should take into account that the thermal conductivities of air gaps are adjusted to include the conduction and radiation heat transfer in real situation, and correlated with the actual temperatures on the gap counters, so as it is in the ISO standard. And the equivalent air gap conductivity calculations are automated in the Excel spreadsheet. Now let's go to QuickField and take a look on this problem. First, let's take a look at the problem properties. This is the steady-state heat transfer problem, and the model class is playing parallel. The other settings are given here. This is the geometry model. Here we have air blocks, 6 air blocks totally. Number 1, general connectivities of the air blocks are the same. This is the initial thermal conductivity for the Excel spreadsheet. So we have some other blocks like aluminium, EPDM, insulation panel, and software. We have 4 edge labels here as well. On this edge we have a zero flux outer condition. This is the cool side, the convection boundary condition, and this is the warm side divided with 2 edge labels, this one and this one. Now let's go to the Excel spreadsheet. That's how it looks like. We have a brief instruction regarding usage of this spreadsheet. And to get started, we should list it. We should list the area block labels. In this problem we have 6 area blocks, and also we should mark the type in the second column. That is the 1 for isolated cavity and 2 for slightly insulated type. And also one should set initial conductivity in the C column. So let's get started. This is the result for the first iteration. One can see that the error is pretty huge. Let's do another step. And a few more steps. Well, after the 8 iterations, we have a pretty small value of the error. This is the temperature distribution obtained in QuickField. And now we can calculate equivalent general conductance. To do this, we should add some labels, some edges into the contour of integration. So now it's done. We select the integral calculator to calculate heat flux, and the value is about 8.3 watts. Now we are dividing this value for the temperature difference of 20 degrees, and we get the value of equivalent general conductance. And one can see that this value matches the reference one pretty good.